Welcome to the Podlets podcast.
All right. Hello, everybody, and welcome to episode 6 of the Kubelets podcast. Today, we are going to be discussing the concept of stateful and stateless and what that means in this crazy cloud-native landscape that we all work. I am Josh Rosso. Joined with me today is Carlicia.
Hi, everybody.
We also have Duffy.
Hey, everybody.
Nicholas.
Yo.
And a newcomer to the podcast, we also have Brian. Brian, you want to give us a little intro about yourself?
Hi, I'm Brian. I work at VMware. I do lots of community stuff, including chairing the KubeCon / Cloud Native Con.
Awesome. Cool. All right, so we've got a pretty good cast this week. So let's dive right into it. I think one of the first things that we've been talking a bit about is, the concept of what makes an application stateful, and of course in reverse, what makes an application stateless. So maybe we could try to start by discerning those two. Maybe starting with stateless, if that makes sense. Does someone want to take that on?
Well, I'm going to jump right in. I have always been a developer, as opposed to some of you or all of you who have a system admin backgrounds. And the first time that I heard the stateless app, I was like, what? It's like, I'm talking about, that wasn't recent, okay? It was a long time ago, but it just like, there was a knot in my head, like, why would you have a stateless app? Like, if you have an app, you're going to need states. Like, I couldn't imagine what that was. But of course, it makes total sense now. Like, that was also when we were more in the monolithic worlds. So, I'm sorry, what was the question again?
Actually, that's a good point. Before you go into that, that's a great point. Whenever we start with apps, or we start developing apps, we think of an application. An application does everything. It takes input and it does stuff and it gives output. But now in this new world where we have lots of apps, big apps, small apps, we start finding that there's apps that only talk and coordinate with other apps. And they don't do anything else. They don't save any data. They don't do anything. And that's what we get into this thing called stateless apps. Apps don't have any type of data that they store locally.
Yeah, it's more like when I envision in my head, like you said it brilliantly, Brian, it's almost like a process. Like when I started envisioning this world of stateless apps, to me, it's like, why do we even call them apps? Why don't we just call them a process? They just like shifting data back and forth, but they're not. To me, at the beginning, apps were always stateless. They went together.
I think frequently people think of applications that have only locally relevant state, stuff that is actually not going to persist to disk, but like maybe held in memory or maybe only relevant to the type of connection that's coming through that application, also as stateless, which is interesting because there's still some state there, but the premise is that you could lose that state and not lose the functionality of that code.
So something that we might want to dive into really quickly when talking about stateless and stateful apps, what do we mean by the word state? Because when I first learned about these things, that was what always screwed me up. I'm like, what do you mean state? Like Washington? Like, yeah, we got it right here.
State. That's that word. State is one of those words that we use to sound smarter than we actually are. 95% of the time, and that's a number I just made up, when people are talking about state, they mean databases. Yeah. But, there's other types of state as well. If you maintain local cache that needs to be persistent, if you have local files that you're dealing with, like you're opening files, that's still state.
Exactly.
So state really is just that. It's just that data that must persist.
Yeah.
I agree with that definition. I think that state, whether it persisted to memory or persisted to disk or persisted to some external system, that's still what we refer to as state.
All right. Yeah, that makes sense and sounds about like what I got from it as well.
All right. So now we have this world where we talk about stateless apps and stateful apps. Are there even stateful apps? Like, do we call a database an app? If we have a distributed system where we have one stateless app over here, another stateless app over there, and then we have the database that's connected to the two of them, are we calling the database a stateful app? Or is that whole thing, how do we call this?
Yeah, the database is very much a state, is an app with state. Very much.
Simplest definition, yeah.
Yeah, it's literally, it's the epitome of a stateful app. But then you also have these apps that talk to databases as well, and they might have local data, like data that they start a transaction and then complete it, or they have a long distributed type transaction. So any apps that revolve around a database, if they store local data, whether it's within a transaction or something else, they're still stateful apps.
Yep. Anything that's going to modify input data or do compute, or modify state that has to be persisted in some way, I think is a stateful app. Even though I do think it's confusing because a lot of, as I said before, I think that there are a bunch of applications that we think of like, not everybody considers Spark jobs to be stateful, right? Spark jobs, for example, are something that would bring data in, mutate that data in some way, produce some output, and then go away. And the benefit, and the definition there is that Spark would generally push the resulting data into some other external system. So it's interesting because in that model, right, Spark is not considered to be a stateful app because the Spark job could fail, go away, get recreated, pick up the pieces where it left off, or just redo that work until all of the work is done. And so in many cases, people consider that to be a stateless application. And that's, I think, like the crux, in my opinion, the crux of the confusion around what a stateful and stateless application is that people frequently, it really is about, I think it's more about where you store, what you mean by persistence, and how that it actually realizes in your application. If you're pushing your state to an external database, is your application still stateful?
I think that's a good question. Or if you are gathering data from an external source and mutating it in some way, but you don't need data to be present when you start up, is that a stateful app or stateless app? Even though you are taking in data, modifying it, and chunking it out and sending it out to some other mechanism, or serving it in your own way, does that become like a sales app? Like if that app gets killed and it comes back and it's able to recover, is it stateful or stateless, right? And that's a bit of a gray area, I think.
Yeah, I feel like a lot of the customers I work with, if the application can get killed, even if it had some type of local state, right? They still refer to it as stateless usually, to me at least, when we talk about it, because they think, I can kind of restart this application and I'm not too worried about losing whatever it may have had. Let's say cached for simplicity, right? And I think that kind of leads us into an interesting question. We've talked a lot on this podcast about cloud native infrastructure and cloud native applications. And it seems like since the inception of cloud native, there's always been this push that like a stateless app is the best candidate to run or the easiest candidate to run. And I'm just curious if we could dive into that for a moment. Like, why in the cloud native infrastructure area has there always been this push for running stateless applications? Why is it simpler? Those kind of things.
Well, before we dive into that, we have to realize, and this is just a problem with our whole ecosystem, this whole cloud native, we're very hand wavy in our descriptions for things. There's a lot of ambiguous descriptions, and state is one of those. So just keep that in mind, that when we're talking today, we're just trying to get through this community. We're really just talking about these things that store data, and that's the state. So just keep that in mind as you're listening to this. But when it comes to distributed systems in general, the easiest system is a system that doesn't need coordination with any other system. And if it happens to die, that's okay. We can just restart it. So people like to start there. It's the easiest thing to start with.
Yeah, that's basically what I was gonna say. Like, if your application needs to tie into other applications, it becomes significantly more complicated to like implement it, at least for your first time in a new system. So like these small applications that they don't care about anybody else, they just take in data or not, they just do whatever. Those are super easy to start with because you're just like, here, start this up. Who cares? Like, whatever happens, it happens.
That could be a good boundary to define. I don't want to jump back too far, but to define what is a stateless app, to me, is it part of a system, and does it depend for it to come back up? Does it depend on something else that has states?
Well, I'll give you an example. I can give you a good example of a stateless app that we use every day. Every single one of us. None of us own it on this call, but when you search Google, you go to google.com and you go to the bar and you type in a search. What's happening is there is a service at the beginning that collects that search, and it federates the search over many different, probably clusters of computers, so they can actually do the search concurrently. That app that actually coordinates all that work is a stateless app, most likely. And all it does is just splits it up and allows more CPUs to do the work. So probably if it goes away, probably not a problem. We probably have 10 more of them. That's what I consider stateless. It doesn't really own any of the data. It's the coordinator.
Yeah, and when if it goes down, it comes back up. It doesn't need to reset itself to the state where it was before. So it can truly be considered stateless because it can just, okay, I reset. I'm starting from the beginning, from this like clear states.
Yes, that's a good summary of that.
Because another way to think about stateless in state, like what makes an app a stateful app would be, does it have to be combined, like deployed and shipped together with the part that maintains the state? That's a more clear-cut definition. Then that app is definitely a stateful app.
What we frequently talk about in like the cloud native space is like, if you know that you have a stateless app, if you can just create 20 of them and not have to worry about the coordination of them, right? They are all workers. They're all going to take input. You can spread the load across those 20 in an identical way and not worry about which one you landed on. That's a stateless application. A stateful application is a very different thing. You have to have some coordination. You have to say, how many databases can you have on a back end, right? And because you're persisting data there, you have to be really careful about like making sure that you only have that you only write to the master database or to the writing database, right? And you could read from any of the other members of that database cluster, that sort of stuff, right?
And it might seem that we are it might seem that we are going so deep into this like differentiating between stateful and stateless, but this is so important because clusters are usually designed to be ephemeral. So ephemeral means obviously, they die down, they're brought back up, the nodes, and you should worry as least as possible with the state of things. And then going back to what Josh was saying, when we are in this cloud native world, usually we are talking about stateless apps, stateless workloads, and then we're going to talk about what workload means. But then if that's the case, where are the stateful apps? Like we have this division that the stateful apps live outside the cloud native worlds. How does it work? It's supposed to work.
No, this is the question that keeps a lot of people employed.
Yep.
Making sure my state is available when I need it. Or actually, you know what? I'm not going to even use that word state. Making sure my data is available wherever I need it and when I need it. So this is, without getting, I don't want to go too deep in right now, but this is actually a huge problem in the Kubernetes community in general. And we see it because there's been lots of advice given don't run things like databases in your clusters. And then this is why we see people taking the ideas of Google Spanner and like in CockroachDB and actually going through a lot of work to make sure that you can run databases in Kubernetes clusters. But the interesting piece about this is that we're actually to the point where we can run these types of workloads in our clusters, but with the caveat, big star at the end, it's very difficult and you have to know what you're doing.
Yeah, and I want to dovetail on that, Brian, because it's something that we see all the time. Like, I feel like when we first started setting up, let's call them clusters, but in our case, it was Kubernetes, right? We always saw that data level always being delegated to, like, if you were in Amazon, some service that they hosted and so on. But now I think more and more of the customers that at least I'm seeing, I'm sure Nicholas and Duffy too, they're interested in doing exactly what you just described. Cockroach is an example I literally just worked with recently. And it's just interesting how much more thoughtful they have to be about their cluster operations. Going back to what you said, Carlicia, it's not as easy as just like trashing a cluster and instantiating a new one anymore like they're used to. They need to be more thoughtful about keeping that data integrity intact through things like upgrades and disaster recovery.
Go ahead, Duffy.
Another interesting point to me, kind of to your point, Brian, is that like frequently people are starting to have conversations and concerns around data gravity, which means that I have a whole bunch of data that I need to work with, right? Like these Spark jobs that I mentioned earlier, and I need to basically put my compute where that data is. Now, whether I store that data inside the cluster and use Kubernetes to manage it, or whether I just have to make sure that I have some way of bringing up compute workloads close to that data, it's actually kind of introducing a whole new layer to this whole thing.
Yeah, and a whole new layer of work and a whole new layer of complexity. Because that's actually the crux of all this. It's like where we slide the complexity to. But this is interesting, and I don't want to go too far into this one, definitely. And this is why we're seeing more people creating operators around managing data. Like I've seen operators for bringing databases up inside of Kubernetes. I've seen operators that actually can bring up resources outside of Kubernetes using the Kubernetes API. And the interesting thing about this is that I look at both solutions and I said, I still don't know what the answer is. And that's great. That means that we have lots to learn about this problem. And at least we have some paths forward.
Actually, that kind of reminds me of the first time I ever heard the word stateful or stateless, so I'm an infrastructure guy, was around the discussion of operators, which, it was only a couple of years ago when operators were first introduced at CoreOS. And some people were like, oh, well, this is how you now operate like a stateful mechanism inside of Kubernetes. Like this is the way forward that we want to propose. And I was just like, cool. What is that? What state? What do you mean stateful and stateless? I had no idea. And, Josh, you were there. You're like, well, your front end doesn't care about state and your back end does. And I'm like, does it? I don't know. I'm not a developer. So to me, I was like, oh, whatever.
Let's talk about exactly that, because I think these patterns we're starting to see are coming out of the needs that we're all talking about, right? So we've seen, at least in the Kubernetes community, a lot of push for these different constructs, like something called a stateful set, which isn't that important right now, but then also like an operator. So maybe we can start by defining what is an operator? What is that pattern and why does it relate to stateful apps?
I think that would be great. I am not clear on what an operator is. I know there's going to be a controller involved. I know it's not a CRD. I'm not clear on that at all, because I only work with CRDs, and we don't define, the project I work on with Valero. We don't categorize it as an operator. I guess an operator uses a specific framework that exists out there. Is it a Kubernetes library? I have no idea.
So we did it to ourselves again. We keep on doing this to ourselves. So from the best that I can surmise, an operator is the operator pattern is the combination of a CRD plus a controller that will operate on events from the Kubernetes API based on that CRD's configuration. That's what an operator is.
That's exactly right.
You conflate this. Red Hat created the operator SDK. And then you have Cube Builder, and you have a meta controller, which can help you build operators. And then we actually sometimes conflate and call CRDs operators. And that's pretty confusing for everyone. So once again, don't let developers name anything.
Wait, so let's back up a little. Okay, so there is an actual library that's called an operator.
Yes, there's an operator
Referred to
SDK.
as an operator.
Right.
Okay.
Yes.
Right.
I heard that. Okay, great. So, but
the word
let me back up a
operator
little, because if you are developing an app for Kubernetes, if you're extending Kubernetes, you are okay. You might not use CRDs, but if you are using CRDs, you need a controller, right? Because how will you do actions? So then every app that has a CRD, because the alternative to having CRDs is just using the API directly without creating CRDs to reflect your resources.
Mm-hmm.
So if you're creating CRDs to reflect your resources, you need controllers. So all of those apps that have CRDs are operators.
Yep.
Yeah.
Valero is an
What
operator.
is not an operator? Like, well, how can you extend Kubernetes and not be qualified as an operator?
Well, there's a way. There is a way. You can actually just create a CRD and use the CRD for data storage. Store states, and you can actually query. You can actually query the Kubernetes API for that information. You don't need a controller, but we couple them with controllers a lot to perform action based on that state. We've saved to etcd.
Duffy.
I think we should, I want to back up just for a moment and talk about the controller pattern and what it is, and then go from there to operators, because I think it makes it easier to get in your head. So control pattern is like, it is effectively a way to understand desired state and real state and provide some logic or business code or that will allow you to converge those two states, right? Your actual state and your desired state. And this is a pattern that we see used in almost everything within a distributed system. It's like within Kubernetes, within most of the kind of more interesting systems that are out there, this control pattern describes a pretty good way of actually managing application flow across distributed systems. Now, operators, when they were initially introduced, we were talking about that this is a slightly different thing. Operators, I hate my microphone, sorry. I'm gonna fix this thing. All right, so operators, when we introduced the idea, came more from like the operational burden of these stateful applications, like things like databases and those sorts of stuff. And with the database, like etcd, for example, you have a whole bunch of operational and runtime concerns around managing the lifecycle of that system, right? How do I add a new member to the cluster? What do I do when a member dies? How do I take action, right? Right now, that's somebody like myself waking up at 2 a.m. and working through a run book to basically make sure that service remains operational through the night. But the idea of an operator was to take that control pattern that we described earlier and make it wake up at 2 a.m. to fix this stuff, right? We're going to actually codify the operational knowledge of managing the burden of these stateful applications, so that we don't have to wake up at 2 a.m. and do it anymore. Nobody wants to do that.
So yeah, that makes sense. And I'm remembering back at KubeCon years ago, I know it was one in Seattle, where Brandon Phillips was on stage talking about operators. He basically was saying, if we think about like sysop, system operators, it was a way to basically automate or capture the knowledge of our system administrators in scripts or in a process or in code, a la operators.
Yep.
The last part that I'll add to this thing, which I think is actually what really describes the value of this idea to me, right, is that there are only so many people on the planet that do what the people in this blog post do. Maybe you're one of them listening to this one, or sorry, that listen to this podcast, right? Like people who are operating software or operating infrastructure at scale, there just aren't that many of us on the planet, right? And so as we add more applications, as there's more, as people adopt this cloud native regime or start, coming to a place where they can crank out more applications more quickly, we're going to have to get to a place where we are able to automate the burden of managing those applications, because there just aren't enough of us to be able to support the load that is coming. Like there just aren't enough people on the planet that do this to be able to support that. And so that's the thing that excites me most about the operator pattern, is that it gives us a place to start. It gives us a place to actually start thinking about managing that burden over time, because if we don't start changing the way we think about managing that burden, we're gonna run out of people. We're not going to be able to do it.
Yeah, so it's interesting with so stateful apps. We keep kind of come back to stateful apps because stateful apps are hard and stateless apps are easy. And we've created all these mechanisms around operating things with state because of how just complicated it is to make sure that your data is ready, accessible, and has integrity. That's the big one that I keep not thinking about as a sysops person coming into the dev world. Data integrity is so important, and making sure that your data is exactly what it needs to be and was the last time you checked it is super important. It's only something I'm really starting to grok. And that's why these things like operators and all these mechanisms that we keep creating and recreating keep coming about, because making sure that your stateful apps have the right data at the right time is so important.
So, since you brought this up, have we actually talked about why state is so hard? I want to introduce a new term to this conversation, the whole cap theorem, where data would typically be, in a distributed system at least, your data will be consistent, or your data can be available, or if your distributed system falls in multiple parts, it can be, you can have partition tolerance. And this is one of those neat computer science things where you can actually pick two. So you can have it be available and have partition tolerance, but your data won't be consistent, or you can have consistency and availability, but you won't have partition tolerance. So if your cluster splits into two for some reason, you won't actually, the data will be bad. And this is why it's hard. This is why people have written basically lots of PhD dissertations on the subject. And this is why we are talking about this here today, is because managing state, and particularly managing distributed state, is actually a very, very hard problem. But there's software out there that will help us, and Kubernetes is definitely part of that, and stateful sets are definitely part of that as well.
Yeah.
Yeah.
Go ahead, Josh.
I was just going to say on those 3 points, the consistency, availability, and partition tolerance, obviously we'd want all three if we could have them, right? Is there one that we most commonly trade off and give up, or does it go case by case?
So actually, it's been proven you can't have all three. It's literally impossible. So it depends. Like if you have a MySQL server and you're using MySQL to actually serve data out of this, you're going to most likely get consistency and availability. If you have it replicated, you might not have partition tolerance. So that's something to think about. And there's different databases, and this is actually one of the reasons why there are different databases. This is why people use things like relational databases, and they use key value stores. They're not because we really like the interfaces, but because they have different properties around the data.
That's an interesting point, and something that I had recently just been thinking about, like, why are there so many different databases? I just didn't know, and it was like I only recently heard of cap theorem as well, just before you mentioned it, and I'm like, wow, that's so fascinating. The whole thing where you only pick two, you can't get three. Josh, to kind of go back to your question really quickly, I think that partition tolerance is the one that we throw away the most. We're willing to not be able to segregate our database as much as possible because the C and A are just too important, I think. At least that's what I'm saying. Like, I'm wearing an etcd shirt, and etcd is not partition tolerant. It's bad at it.
Well, this is why Google introduced Spanner, and Spanner in some situations can get 3 with trade-offs and a lot of really, really smart stuff, but most people can't run this scale. But we do need to think about partition tolerance, especially with data. Whenever, let's say you have you run a store and you have multiple instances across the world, and someone buys something from inventory. What does your inventory look like at any particular point? And you don't have to answer that question, of course, but think about that. These are still very important problems. If fiber gets cut across the Atlantic, and now I'm sold more things than I have.
Mm-hmm.
So, Carlicia, speaking to you as someone who's only been a developer, have we moved your thoughts on state any further?
Well, I feel that I'm clear on, well, I think you need to qualify your question better for me. If you're asking if I understand what it means, I understand what it means. But I actually was thinking to ask this question to all of you. Do you, because I don't know the answer, if that's the question you're asking me, I want to put that to the group. Do you recommend people, as in like now-ish, to run stateful workloads? We need to talk about what workloads mean. To run stateful apps or database inside, if they're running a Kubernetes cluster, if they're planning for that, do you all as experts recommend that they should already be looking into doing that? Or they should be running for now their stateful apps or databases outside of the cloud native ecosystem and just connecting the two? Because if that's what your question was, I don't know.
So I'll take this first. I think that we should be spending lots more time than we are right now in coming up with community tested solutions around using stateful sets to their best ability. And what that means is, let's say if you are running a database inside of Kubernetes and you're using a stateful set to manage this, what we do need to figure out is what happens when my database goes down, the pod just kills. And when I bring up a new version, I need to make sure that I have the correct software to verify integrity, rebuild things, so that when it comes back up correctly. That's what I think we should be doing.
Yeah, and for me, I think with working with customers, at least Kubernetes-oriented folks, when they're trying to introduce Kubernetes as their orchestration part of their overall platform, I'm usually just trying to kind of meet them where they're at. If they're new to Kubernetes and distributed systems as a whole, if we have stateless, let's call them maybe simpler applications to start with, I generally have them lean into that first because we already have so much in front of us to learn about. I think it was either Brian or Duffy who said, like, it introduces a whole bunch more complexity, right? You have to know what you're doing. You have to know how to operate these things. So if they're new to Kubernetes, I generally will advise starting stateless still. But that being said, so many of our customers that we work with are very interested in running stateful workloads on Kubernetes.
But just to qualify what you said, Josh, because you spoke like an expert, but I still have beginner's ears. You said something that sounded to me like you recommend they go stateless. So that's how it sounded to me, like that. So what you're really saying is that they take out the stateless part of what they have, which they might already have or they might have to change, and put the stateless. You're not suggesting that, oh, you can do stateful anymore. You need to just do everything stateless. What you're saying is take the stateless part of your system, put that in Kubernetes, because that is really well tested, and keep the stateful outside of that ecosystem. Is that right?
I think that's a better way to put it. And again, it's not that Kubernetes can't do stateful. It's just it's more of a concept of biting off more than you can chew.
Yeah.
Right. We still work with a lot of people who are very new to these distributed systems concepts, and to take on running stateful workloads, if we could just delegate that to some other layer, like outside of the cluster, that could be a better place to start. At least in my experience. Nicholas and Duffy might have different.
Yeah.
I actually. Oh. Josh, you basically like nailed it, like what I was going to say, where it's like, if the team that I'm working with is interested in taking on the complexity of maintaining their databases, their stateful sets, and making sure that they have, data integrity and availability, then I'm all for them using Kubernetes for a stateful set. Kubernetes can run stateful applications, but there is all this complexity that we keep talking about of maintaining data and all that. If they're willing to take on that complexity, great. It's there for you. If they're not, if they're a little bit, kind of behind, not behind, but if they're kind of starting out their Kubernetes journey or their distributed systems journey, I would recommend them to move that complexity to somebody else and start with something a little bit easier, like a stateless application. And there are a lot of good services that provide data as a service, right? You've got AWS RDS is great for like just creating a stateful application that you can leverage at any time, and you've got like dedicated wires to. So I would point them to there first if they don't want to take on that complexity.
I completely agree with that. There's one thing I would add, which is in response to the stateful set piece here, is that, as we've already described, managing a stateful application like a database does come with some complexity. And so you should really carefully look at just what these different models provide you, right? Whether that model is making use of a stateful set, which provides you like ordinality, ensuring that things start up in a particular order, and some of the other capabilities around that stuff. But it won't, for example, manage some of the complexity. Like it won't, a stateful set won't, for example, try and issue a command to the new member to make sure that it's part of an existing database cluster. It won't manage that kind of stuff, right? So you have to really be careful about the different models that you're evaluating when trying to think about how to manage a stateful application like a database. There are, I think this is actually why, the topic of an operator came up kind of earlier, which was that like there are a lot of primitives within Kubernetes in general that provide you a lot of capability for managing things like stateful applications, but they may not entirely suit your needs. And so because of the complexity of a stateful application, you have to really kind of be really careful about what you adopt and where you jump in.
Yeah, and I know just from working with Velero, which is a tool for doing backup and recovery and migration of Kubernetes clusters, I know that we back up volumes. So if you have something mounted on a volume, we can back that up. So I know for fact that people are using that tool to back up stateful workloads. We need to talk about workloads. But in any case, one thing I think one of you mentioned is that you definitely also need to look at backup and recovery strategy, which is ever more important if you're doing stateful workloads.
Yeah, I would say that's the only time it's important. If you're doing stateless, who cares?
So have we defined what a workload is?
Yeah, but let me say something. So yeah, I think we should do an episode on that. Maybe not. We should do an episode on GitOps type of thing, infra related things, because even though things are stateless, but I don't want to get into it. Your cluster will change states. You can recover it and stuff from like a fresh version, but as it goes through a life cycle, it will change states, and you might want to keep that state. I don't know. I am not the expert in that area, but let's talk about workloads, Brian. Why? Okay, let me start talking about workloads. I never heard the term workload until I came into the cloud native world. And that was about a year ago, or when I started looking into this space more closely, maybe a little bit before a year ago. And it took me forever to understand what a workload was. Now I understand, especially today, we were talking about it a little bit before we started recording. So let me hear from you all. What it means to you.
So this is one of those terms, and I'm sure if I go ask any ex-Googlers about this, they'll probably agree. This is a Google term that we actually have zero context about why it's a term. I'm sure we could ask somebody and they would tell us. But workloads, to me, personally, are anything that ultimately creates a pod. So deployments create replica sets, create pods. That whole thing is a workload. That's how I look at it.
So before there were pods, were there workloads? Or is a workload like a new thing that came along with pods?
No, once again, these words don't make any sense to us because they're Google terms. But I think that a pod is part of a workload, like a deployment is part of a workload, like a replica set is part of a workload. Workload is the term that encompasses that entire set of objects.
I think of a workload as a subset of an application. So when I think of an application or a set of microservices, I might think of each of the services that make up that entire application as a workload. And I think of it that way because that's generally how I would divide it up, to Brian's point, into different deployments or different stateful sets or different, that's that sort of stuff, right? I'm thinking of them each as their own autonomous piece, and all together they form an application. That's my take on it.
Yeah, to connect to what Brian said, deployments will always run in the pods, which is super confusing if you're not looking at these things, just so people understand, because it took me forever to understand that. The connection between, a workload, a deployment, and a pod. So pods contain, if you have a deployment that you're going to ship to Kubernetes, I don't know if ship is the right word, you're going to run on Kubernetes, that deployment needs to run somewhere in some artifact, and the artifact is called a pod.
Mm-hmm. Yeah, kind of on going back to what Duffy said really quickly, a workload to me was always a process, kind of like not just a pod necessarily, but like whatever it is that you're like, I just need to get this to run, whatever that is. To me, that was always a workload, but I think I'm wrong. I think I'm oversimplifying it. But I'm just like, whatever your process is.
Yeah, I would give you, the reason why I would not say that is because a pod can run multiple containers at once, which ergo is multiple processes. So
Damn, you're right.
That's why I say it that way.
Oh, you changed my mind.
The reason I bring this up, and this is probably a great idea for a future show, is about all the jargon and terminology that we use in this land that we just take as everyone knows it, but we don't all know it, and it would just be a great conversation to have around that. But the reason I was bringing up the whole workload thing is because when we think about workloads, and then you can't have state without workloads, really. And I just wanted to make sure that we tied those two things together.
Why can you not have state without workloads? What does that mean?
Well, the reason you can't have state without workloads is because something's going to have to create that state. Whether that workload is running in or out of the cluster, something's going to have to create it. It just doesn't come out of nowhere. So
that goes back to what Nick was saying, that he thinks a workload is a process. Was that what you said, Nick?
It is, yeah, but I'm renegating on that.
What I'm saying is that it's
at least I can see why you
process.
said that.
Yeah.
Sorry, Brian, I cut you off. Say it again.
Oh, what I was saying is a workload ultimately is one or more processes. It's not just a process, it's not a single process. It could be 10, it could be 1.
Yeah.
I have one final question, and we can just bail on this and edit it out if it's not a good one to end with. I hope it's not too big, but I think maybe one thing we overlooked is just why it's hard to run stateful workloads in these new systems like Kubernetes. We talked about how there's more complexity and stuff, but there might be some room to talk about, people have been spinning up a EC2 server, a server on the web, and running MySQL on it forever. But why in the Kubernetes world of pods and things, is it a little bit harder to run, say, MySQL just natively? Is that something worth diving into?
Yeah, I think so. I would say that for things like stateful applications like databases particularly, they are less resilient to outages. And while Kubernetes itself is dedicated to, or most container orchestrations, but Kubernetes specifically, are dedicated to running your pods continuously as long as they will, that it is still somewhat of a shifting landscape. You do have like priority and preemption. And if you don't set those things up properly, or if there's just like a total failure of your system at large, your stateful application can just go down at any time. And then how do you reconcile the outage data, whatever data that might have gotten lost, those sort of things become significantly more complicated in a environment like Kubernetes, where you don't necessarily have access to a command line to run the commands to recover as easy. You may not, that is to say.
Yes, and you got to understand what databases do. Disk is slow, whether you have spinning disk or you have disk on chip, a la like SSD. So what databases do in a lot of cases is they store things in memory. So if it goes away, it can get stored. And then in other cases, what databases do is they have these huge transaction logs. Maybe they write them out in files, and they process the transaction log whenever they have CPU time. So if a database dies just suddenly, maybe its state is inconsistent because it had items that were to be processed in a queue that haven't been processed, and now it doesn't know what's going on. Which is
That's
why
interesting. I didn't know that.
If you kill MySQL like a kill MySQL D with a -9, why it might not come back up.
Yeah, and going back to like Kubernetes as an example, like we are living in this newer world where things can get rescheduled and moved around and killed, and their IPs change and things. So it seems like this environment is, should I say, more ephemeral, right? And those types of considerations become more complex.
Mm-hmm. I think that really nails it. Yeah. I didn't know that about transactional logs about databases. I feel like have known that, but I just had no idea.
So there's one more part to the whole stateful, stateless thing that I think is important to cover, but I don't know if we're going to be able to cover it entirely in the time that we have left. And that is from the network perspective, right? When we think about the types of connections coming into an application, we refer to some of those connections as stateful and stateless. Do you think that's something we could tackle in our remaining time, or?
Why don't you try giving us maybe a quick summary of it, Duffy, and then we can end on that.
Yeah, I think it's a good idea to talk about network and then address that in the context of network. I'm just thinking, an idea for an episode, but give us like a quick rundown. Sure.
So a lot of the kind of, older monolithic applications, the way that you would scale these things is you would have multiple of them. And then you would have some intelligence in the way that you were routing connections down to those applications that would describe the ability to ensure that when, Bob accesses a website and he authenticates, he's going to authenticate to one specific instance of this application. And the intelligence up in the front end is going to handle the routing to make sure that Bob's connection always comes back to that same instance. This is an older pattern. It's been around for a very long time. And it's certainly the way that we first kind of learned to scale applications before we decided to break into microservices and kind of handle a lot of this routing in a more resilient way. That was kind of one of the early versions of how we do this. And that is a pretty good example of a stateful session in that there is actually some, like perhaps Bob has authenticated and he has a cookie that allows him to allows him that when he comes back into that particular application, a lot of the settings, his browser settings, whether he's using the dark theme or the light theme, that sort of stuff is persisted on the server side rather than on the client side. And so there's a lot of that's kind of what I mean by stateful sessions. Stateless sessions mean it doesn't really matter that the user is terminating to the same endpoint, because we've actually managed to keep the state either with the client. We're handling state on the browser side of things rather than on the server side of things, and so you're not necessarily gaining anything by pushing that connection back to the same specific instance. but just to a service that is more widely available. And there are lots of examples of this. I mean, Brian's example of Google earlier, right? Like obviously when I come back to Google, there are some things I wanted to remember. I wanted to remember that I'm logged in as myself. I wanted to remember that I've used a particular, I wanted to remember my history. I wanted to remember that kind of stuff so that I could go back and find things that I looked at before. There's a ton of examples of this when we think about it.
Awesome. All right, everyone. So thank you for joining us in episode 6, Stateful and Stateless. Signing off, I'm Josh Rosso, and going across the line, thank you, Nicholas Lane.
Thank you so much. This was really informative for me.
Carlicia Campos.
This was a great conversation. Bye, everybody.
Our newcomer, Brian Lyles.
Until next time.
And Duffy Cooley.
Thanks a bunch, everybody.
Thanks all.
Bye.